Hello friends. In the previous modules, we had studied the introduction to FEA and the general procedures to solve an FEA problem. As we all know, FEA is nothing but a numerical method to solve the differential equation. So, in today's module, we'll be looking at what are differential equations. In order to understand, let us begin by understanding the concept of variables. So, in the lower classes, we have understood what functions stand for. A function always consists of a variable as well as a constant. By the word constant, we understand that it is any value for the function which does not change. On the other hand, a variable is a value for which a quantity can change with respect to different conditions. Let's have a look at it. So, a quantity which can change with respect to different conditions is called as a variable. Let's see an example. Y is equal to 5x square minus 2x plus 1. In this equation, the value of x can be chosen as per our choice. But on the other hand, the value of y depends on the values of x, which we have assumed. Hence, y is called as a dependent variable, whereas x is called as an independent variable. Now, let us understand the meaning of differential equations. Let us consider the equation y is equal to f of x, where x is the independent variable and y is a dependent variable. In the lower classes, we have learned how to differentiate the given function. Hence, we can write the given function as dy upon dx is equal to f dash of x. On further differentiating, we get d square y upon dx square, which is equal to f double dash of x. So, in the above explanation, we have experienced independent variables and dependent variables along with their derivatives. Hence, the equations involving dependent and independent variables along with their derivatives is called as differential equations. As we have understood the definition of differential equations, let us understand the types of differential equations which are usually used in FEA. The first one is called as ordinary equations, whereas the second ones are called as partial differential equations. Let us look at what are ordinary equations. The equations which have one and only one independent variable and one or more dependent variables are called as ordinary equations. Let us consider an equation. Dy upon dx plus dt upon dx is equal to theta. Here, if we observe carefully, we understand that x is the only independent variable, whereas y and t are the dependent variables. Now, let us have a look at partial differential equations. The differential equations in which there are one or more independent variables and one or more dependent variables are called as partial differential equations. Let us consider a differential equation, that is dy upon dx plus dt upon du plus u is equal to e raised to x minus y. In this differential equation, x and u are independent variables, whereas y and t are dependent variables. So, in ordinary equations, we have an independent variable and one or more dependent variables, whereas in partial differential equations, we have one or more independent variables and one or more dependent variables. So, I hope by now we have understood differential equations and its types. Now, let us look at a very important concept from this module, that is order and degree. The order is the highest number derivative in the equation, while the degree is the highest power in which a derivative is raised. In mathematical terms, the order is then given by the highest order of the derivative in this equation, whereas the degree is defined as the highest degree of the derivative in the equation. Let us consider an equation d square y upon dx square minus 5 dy upon dx plus x, which is equal to 0. Here, the differential equation has the highest order of the derivative as 2. Also, the highest degree of the derivative is 1. In the previous module, we understood the meaning of order and degree. Now, let's take some examples on order and degree to clear our concepts on the above. Consider the equation d square y upon dx square, the whole square plus dy upon dx raised to 3 plus y cube is equal to 0. First, let's check for the derivative with the highest order. We can clearly see that 2 is the biggest number with respect to the derivative. Also, the degree of the respective derivative is 2. Students, please do not get confused by seeing the number 3 in dy upon dx. Many students think that the order of this equation would be 3. The order is usually the number within the bracket and between the d and the dependent variable. Hence, we have to consider the degree of the respective derivative having the biggest number. The biggest number in the order of the derivative is 2, whereas the degree of the respective derivative is 2. Hence, the order and degree of the differential equation are 2. Let's take another example. dy upon dx the whole raised to 1 upon 3 is equal to d square y upon dx square. We have to understand that in case of a fraction or root value in any differential equations, we cannot conclude directly on the order and the degree. Hence, we first eliminate the roots or fraction by bringing the equation in normal form. In this case, we take cubes on both the sides to eliminate the cube roots. On the right hand side, the derivative is raised to the power 3. Thus, we can say that since the roots have been eliminated, it is the right time to define the order and degree in the differential equation. Hence, the order of this equation is 2, whereas the degree is 3. While considering this problem on a differential equation, we have been asked to find a solution of it. As we conclude this topic, let us find out how we find a solution of the differential equation. The example is given by y equal to c1 cos 3x plus c2 sin 3x. We get the solution by differentiating the differential equation with respect to x. On differentiating the equations, we get dy by dx is equal to minus 3c1 sin x plus 3c2 cos 3x. On further differentiating, we get the equation as d square y upon dx square is equal to minus 9c1 cos 3x minus c2 sin 3x. On taking minus 9 as common, we get c1 cos 3x plus c2 sin 3x. On carefully observing, we understand that c1 cos 3x plus c2 sin 3x is equal to y. Hence, we substitute c1 cos 3x plus c2 sin 3x as y. Hence, the equation as d square y upon dx square is equal to minus 9y. The important point to notice is that the number of arbitrary constants is equal to the number of differential equations. Hence, this is the solution to the differential equation. That's all for today, students. Thank you for watching the video and do subscribe our channel eKida.